this one, the line integral of scalar field. Integrate 2 plus x squared y ds. S, the lowercase, stand for one small unit of the arc length of the curve C, where the C in this case is the upper half of a unit circle x squared plus y squared equal to 1. So you have the exercise 4D. Evaluate the line integral 2 plus x squared y dy ds. Okay, C is okay. So be only this part because they said it's upper half, okay, of the unit circle. So one unit circle means the radius is 1. So this is 1 0. This is 0 1. So the okay the difficulty is you have to get your own parametric equation. So if you have the unit circle, okay, we may take x like the similar to your r cos theta, you change it to t. So in this case, r, the radius is 1 unit, so it's a cos t, and then the y is sin t. Okay, in first quadrant, so t 0 to pi over 2. So if t from 0 to pi over 2, the curve is anti-clockwise direction, because you can put back this x, this is y. When t 0, plug in cos 0 is 1, sin 0 is 0, so starting point is 1 0. So when t is 1, cos is when t is pi over 2, cos pi over 2 is 0, sin pi over 2 is 1. So starting point from 1 0 to 0 1, so the direction is anti-clockwise. Then you replace x by r cos by cos t, because r is 1, y by sin t. Okay, and then your integral along curve C, so will become t from 0 up to pi over 2. X is cos t, so x squared will be cos squared t. Y is sin t. Okay, to get ds, okay, how you get the ds? Ds is actually square root of the dx dt squared plus dy dt squared dt. Okay, so dx dt difference, you will have, okay, differentiate cos, you have negative sin t, and then you square it. Dy dt mean you, okay, ddt sin t, you have cos t, and then you square it outside dt. So this is sin squared t plus cos squared t is 1. So ds equal to dt. Then you can just directly use your scientific calculator to quickly obtain your integral result. So you just directly use your scientific calculator. We have here 2 plus, okay, the cos squared, I will put cos at oh yeah, cos. So cos, I put bracket and then I squared it, multiply sin. So xk in calculator, only the integral in terms of variable x, so the x from 0 to, make sure in radian. Error, I cannot integrate. Oh, I left out one more closing bracket. 2 plus, okay, cos alpha x squared it sin alpha x. Okay, one more bracket, cos here the integral I open bracket, so I have to close the bracket. So 0 to shift pi divide 2. The answer 3.4749. Okay, answer from module, okay, because it's manually integrate. So you can check 2 pi plus 2, okay, 2/3. Is it equal to 3.4749? Not the same. 3.4749. This is 6.9499. Okay, hold on. Let me check. Okay, the answer is, okay, double of the answer that I obtained. Seems like they integrate 0 to pi. Let me check. Yeah. Delete. Error again. Okay, 2 plus cos. Okay, I got the cos squared. So cos 6.9499. Okay, the answer is let's say integrate 0 to pi. The answer is 6.9499. Okay, check this answer. Oh, 6.9499. I think got, okay, let me see. C is the upper half. Oh, you're right. The upper half, okay, mean is upper part only. Right half is the first quadrant. This is both quadrant. Quadrant 1 and quadrant 2. Okay, upper half. Okay, the words. Upper half of the unit circle. Upper half, okay, so mean is half of the unit circle. Okay, first of all, half of the unit circle, and then take the upper part. So sorry, should be two quadrant. So this is 0 to pi. The answer is 6.9499. So any questions here for question K 1D? So upper half, K, this is quadrant 1 and quadrant 2. The right half, so this is only the, okay, half of the unit circle, and then take a right part. So this one, as I told you in Sunday, is a quadrant 1 and quadrant 4. Later on we check question D. So any questions here?
No, doctor.
If no, also you can have a try question 1D. We jump to question 1D. Question 1D evaluates C. This is x, y power 4 ds. C, they said right half of the, okay, unit circle. I think that the cannot say unit circle. Unit circle, the radius is 1. So it's right half of the circle. Unit circle radius must be 1. So this is right half of the circle x squared plus y squared equal to 4. Because this one r is 4. Okay. And then you say right half means circle half but take the right hand side. So the x squared plus y squared equal to 16. So mean the r is 4. So this point is, okay, x is 0, y is negative 4. Okay, up to x is 0, y is positive 4. Okay, and using the parametric equation for circle, we use, okay, similar to polar coordinate. X is you use r cos theta. Okay, just a theta, change it to t. R is 4. You have the r squared equal to 16. R equal to 4. So 4 cos t. And then y is a 4 sin t. Okay, let's see. Yeah. So this one, let's say we use a anti-clockwise. We check it. Let's say t from negative pi over 2 to positive pi over 2. And then you can check it whether the t, is it correct? But they didn't set the direction. So if I put negative pi over 2 to positive pi over 2, okay, so, okay, I suspect should be the anti-clockwise. This is a t, this is x, this is the y. Yeah? So when t is negative pi over 2, cos, okay, cos pi, okay, or you may press a calc. You have actually, okay, when t is pi over 2, 4 cos negative pi over 2, this is x, this is equal to cos negative, because cos negative is actually the fourth quadrant. Fourth quadrant cos is positive, so this is equal to 4 cos pi over 2. Cos pi over 2 is 0. So x is 0. And then y is 4 sin negative pi over 2. Okay. Sin negative pi over 2 in the fourth quadrant, sin is negative. So it's negative 4 sin pi over 2. Sin pi over 2 is 1, so it's negative 4. So starting from 0, negative 4, mean at the fourth quadrant. And then when t is pi over 2, t is pi over 2, again, okay, when t is pi over 2, cos pi over 2, okay, is 0. So you still get 0. Sin pi over 2 is positive, so this is 0 to 4. So the direction is anti-clockwise. Okay, so now we can, okay, okay, you have x is 4 cos t. So dx dt, you have negative 4 sin t. Then y is 4. Sorry, I record it. Okay. Yes.
Tadi kan doktor tekan dalam kalkulator kan.
Yes.
4 kuasa 6 tu dari mana?
Nah, sebab ini 4. Ini 4 kuasa 4. Ini 4 kuasa 1. So total semua 4 kuasa 6 lah.
Oh,
Ini
faham
4
faham.
kuasa 1. 4 kuasa 1. Terus 4. 4 kuasa 6. Ini cos. Okay. Ini tekan cos x. Ini tekan sin x kuasa 4. Ini cos x.
Oh.
Sin x kuasa 4 saya akan tekan sin x saya letak dia kurungan. Dia kuasa 4. Saya tak tahu dia boleh faham seperti matematik tak. Sin kuasa 4 dekat situ. Okay.
Faham faham.
Hmm.
Terima kasih.
Okay. Okay. A done, B done, D done. Okay. Line segment. Let's see. Similar to 1c similar to 2c. 2c is 3d. Yeah? Re-speak again. So equation 1c, the integrate dsc, this one actually represent the arc length. Okay, arc length of curve C, arc length of curve C. So the line segment 0, 0 to 0, 1, okay, if you sketch, okay, the coordinate is along the y-axis, so x is 0. So let y equal to t. Y move from 0 to 1, because 0 to 1, hence t also from 0 to 1. Okay, and then from x equal to 0, dx dt will be 0, dy dt will be 1. So plug in dx dt, okay, and dy dt into the ds formula. So you have, it's actually, this is 0 squared plus 1 squared dt. So it's third one, so it's ds also equal to dt. Okay, when the integrand of the line integral of scalar field is equal to 1, okay, so this represents the arc length of curve C. So mean the integral, okay, ds along curve C, ds equal to dt, t from 0 to 1. Okay, so you have t from 0 to 1. So the answer is 1. Question 1c. The answer is 1. So the question 1c, question 1c, you may directly on y-axis let x 0, y equal to t, or you use mean you have any starting point, ending point, you may find a vector by taking the ending point 0 minus 0. So this is 0i, 1 minus 0, this is 1j. And then parametric equation is always the starting point of x, add up how many times of component I you multiply with t. And then y will be starting point of y, add up how many times of component j multiply with t. So that will be the parametric equation. But also another one, if you sketch the coordinate, you notice it is on the y-axis, hence x is 0, y equal to t. Y move from 0 to 1, that's why t also move from 0 to 1. Okay, so any questions here? So I repeat, for 2c, x exponent yz ds along curve C. Curve C is the line segment 0, 0 to 1, 2, 3. So if we got, we want to find the parametric equation for line segment that passing through, starting and ending point, then you find a vector, a vector that is parallel with this line segment. To find the vector, you take the ending point, deduct starting point. So 1 minus 0, so you have 1i. 2 minus 0, you got 2j. 3 minus 0, you got 3k. Then the parametric equation will be x. It's a starting point of x. Add up, I here is 1, so 1t. Y will be equal to the starting point of y0 plus j is 2, so plus 2t. Z is starting point of z is 0 plus component k is 3, so plus 3t. Hence x is t, dx dt is 1, and then y is 2t, dy dt is 2, z is 3t, dz dt is 3. And then the ds, you have the dx dt squared plus dy dt squared plus dz dt squared, and then dt outside. So square root, you have 1 squared plus 2 squared plus 3 squared dt. So total is 1 plus 4 plus 9 dt. So I mean total is 14, 14 dt. So ds, okay, replaced by sub 14 dt, x replaced by t, y replaced by 2t, z replaced by 3t. So we integrate respect to t, where the t, okay, if we use this technique, okay, the t is always guaranteed always from 0 to 1. Is it already? Okay, then your equation 2c, the line integral, okay, x exponent y z ds along curve c will be equal to integrate 0 to 1, x is t, y is 2t, z is 3t. Okay, ds we obtain is sub 14 dt. So total you have sub 14, integrate 0 to 1, t, this is exponent 5t dt. Okay, you may use the calculator directly because you got the definite integral. So I got sub 14, integrate t change to x, then exponent, where's the exponent? 2t times 5, 3t, total is exponent 5t. So 5, in calculator t, you change it to x. The x from 0 to 1. You got 88.9995. Okay, 2c. Okay, this is, okay, the answer obtained if you integrate manually. Okay, let's check whether tally with 88.9995. So 14 divide 12. You got exponent 6, and then minus 1. Not the same answer. 125. 125 point. Okay, what we obtain is 88.9995. 125.4792. Is it correct? Let's see. Sub 14 divide 12, exponent 6 minus 1. Okay, hold on, let me check. Okay, the mistake is here. Exponent 2t times 3t is okay, you multiply, this is 6t squared. Mean the mistake is here. Okay, that should be exponent 2 times 3, 6t squared. Okay, unless you got exponents 2t times exponent 3t like this, then the answer is exponent 5t. This is multiply at the index. Multiply at the index. It's not exponent 2t times exponent 3t, then it's exponent 5t. So this one is wrong. Correct one should be exponent 6t squared. Okay, so let's check. So we change it here. 6x squared. So 125.4792. 4792. Okay, 125.4792. Checking out. So this is the answer provided, okay, by integrate manually. 125.4792. So the mistake just now is here. Exponent 2t times 3t should be exponent 6t squared. Okay, what I make, okay, is exponent 5t, which is wrong because exponent 5t provided you got exponent 2t multiply exponent 3t. Okay. Question 1e, integrate 2x ds along curve C, where C consists of the arc C1, of the parabola y equal to x squared from 0, 0 to 1, 1, followed by the vertical line segment C2 from 1, 1 to 1, 2. Question 1E. Yeah? Okay, 1A, integrate 2x ds along curve C, where the C, you have the C1 is from the parabola, C1 parabola y equal to x squared from 0, 0 to 1, 1, followed by the vertical line okay, line 1, 1 to 1, 2. So you got two different curve. Okay, let's sketch the graph. Okay, you got the parabola. This is a parabola y equal to x squared. Okay, but C1 is from, okay, the point here 0, 0 to 1, 1. Okay, let's say this is 1. Yeah. So C1 starting from here, and 0, 0. C1 from 0, 0 to 1, 1. And then they said vertical line 1, 1 to 1, 2. I got vertical line. 1, 1. Oh, go up. Okay, after here, 1, 1, x is 1, y go up to 2. This is 2. So this is curve C1 parabola. Curve C2 is vertical line. So this one, okay, is like a piecewise smooth curve. Curve C1, C2 consists of two different curves. C1 is parabola, C2 is vertical line. Then the curve C, you have to break it. C, you have the C1 plus C2. Then the line integral, you have to break it into two integral. Okay, C1, you have y equal to x squared for C1. Y equal to x squared. Okay, then you let the variable at the right hand side as a x. You let x equal to t. Then y equal to t squared. Okay. Then x move from 0 to 1. See, x move from 0 to 1. This is x. Because x equal to t. Then t also move from 0 to 1. Okay. And then you can find dx dt will be 1. dy dt is 2t. Then you can find the ds for curve C1. Okay, for curve C1, ds, you have the dx dt squared plus dy dt squared. Okay, and then outside of the square root, you got dt. dx dt squared, you have 1. dy dt squared, you have 4t squared. Then outside dt. Okay, this is a curve C1. C2 is a vertical line, vertical line, okay? And the vertical line is actually at x equal to 1. You see, C2 x is equal to 1. So you can see x equal to 1. And then let y equal to t. Okay, y move from 1 to 2. Then t is actually move from 1 to 2. So you see, okay, C2 x is 1. So x is 1. Y equal to t. Y move from 1 to 2. Hence t move from 1 to 2. Then you can find the dx dt for curve C2. dx dt will be 0. The dy dt will be equal to 1. then you find the ds, which is a square root dx dt squared plus dy dt squared, okay, outside dt. So you have actually, this is 0 squared plus 1 squared dt. You have actually ds equal to dt. Okay, then your line integral consists of two different paths. Okay, the line integral 2x ds. Okay, you have to break it into c1 2x, c1 2x ds add up with 2x along curve c2, because curve c break it into c1 and c2. Okay, so for curve c1, okay, look back the parametric equation. Okay, curve c1 x is t, so you have 2t. Okay, ds is here, square root, okay, 1 plus 4t squared dt. And then, okay, for curve c1, x is t, x move from 0 to 1, that's why t also move from 0 to 1. Okay, and along curve c2, t move from 1 to 2, and x is 1. Okay, curve c2 x is equal to 1, so you have 2. Okay, ds is equal to dt. You may, okay, everything using the scientific calculator. Okay, evaluate the first curve first. The first integral, you got 2 t change to x, then square root 1 plus 4, this is 0 to 1. Okay, we check question 1e. Okay, should be the first term here. Okay, later I write down this 1.6967 first. This one 1.6967. Okay, later on, if evaluate, okay, this one 2 dx 2 from 1 to 2, you get the answer is 2. Okay, you get the answer is 2, this part. So we're checking the first term here, which is, okay, the answer by integrate manually. You have 5 power 3 divide 2 minus 1, then divide by 6. Okay, why cannot? Like this. 5 power 3 divide 2, and then minus 1 divide 6. 1.6967. Okay, the first term is the same with us. Yeah, same. So 1.6967. The answer given by module is integrate, okay, by integrating manually. So you add up everything, total is 3.6967. So this is question, okay, 1e, where you curve C consists of C1 and C2, where the C1, where is it? C1 along the curve y equal to x squared from 0, 0 to 1, 1. So for y equal to x squared, let the variable at the right hand side as t. So x is t, and x move from the point 0 to 0, 0 to 1, hence t also from 0 to 1. If x is t, then y equal to t squared. Then you can find dx dt, dy dt, then you can find the ds. So plug in x, y, and the ds into the line integral of scalar field. X is t. ds sub 1 plus 4t squared dt. Okay, the curve C2, x is actually 1. Because they said vertical line from the point 1, 1, vertical line to the point 1, 2. So x is actually at the same position, which is x equal to 1. So dx dt is 0. Okay, x is 1, then y, we let it equal to t. Y move from 1 to 2, hence t move from 1 to 2. So that's why you integrate the second integrate along curve C2, y t1 to 2, x is 1. ds, okay, after you plug in dx dt squared plus dy dt squared, you get is actually 1. So ds equal to dt. Then you use a calculator to obtain the answer directly. So, okay, 3D, then the ds is square root dx dt squared dy dt squared plus dz dt squared. Okay, outside is dt. So ds replaced by this formula, y replaced by sin t, z replaced by t. So similar with question B. Find the dx dt, dy dt, dz dt in order to obtain the ds. Okay. So x replaced by 4 sin t, y replaced by 4 cos t, ds, okay, you have to calculate it. And then it will become integrate respect to t from 0 to pi over 2. Okay, so please do A and B. So we will randomly ask two of you to show the answer. Okay, by I think 10. Okay. To A, let me check the to A. The integral is y sin z d. Why the s like this? ds, lowercase s along curve C. C is x cos t dx dt, negative sin t, correct? Y is sin t, dy dt is positive cos t, which is correct. Z is t, so dz dt is 1, so it's correct. Okay, and then hold on. Okay, chain. So correct, correct, correct. So sin squared, and this is t. This is 1 plus 1, sub 2. Outside got dt. Make sure your square root. Sin squared t plus cos squared t is 1, so 1 plus 1, you should have sub 2 dt. So it's sub
Oh, okay,
2
doctor.
dt.
Okay, okay.
Okay,
So my mistake.
and then y is sin t. Y is sin t. Later on sin z. So z is t. So sin t. Dx is this is ds. Okay, ds is sub 2 dt. Okay, given the t from 0 to 2 pi, then is you have a sin squared t. So integral of okay on integrate sin x. Okay, I put sin x. So I put the bracket and then power 2. Power 2. Okay, x from 0 to 2 pi. And the answer is pi. The answer we obtain is pi. Okay, but the module gives 2 pi. Where is it? Let me check. Y is sin t. Sin z. Z is t. So sin t, sin t. This is cert 2. If I forgot sin 2, oh, yeah, I left out sin 2, cert 2. So it's correct. The answer is, okay, I just evaluate the integral sin x dx. So you still got the, okay, carry the weightage cert 2. So the answer is cert 2 pi. So this is question 2a. So, okay, Meta, your mistake is here. 1
Okay,
plus
doctor.
1, cert 2. Friends, okay. The 2b, the integral x y cube ds along curve C, where the curve C is defined by the parametric equation x equal 4 sin t, y equal 4 cos t, z equal to 3t. So from x equal 4 sin t, you find dx dt, you have 4 cos t. Okay, this one correct. Okay, let me jot down it. Okay, dx dt is 4 cos t, correct. Okay, y 4 cos t dy dt is negative 4 sin t, correct. Okay, z is 3t, dz dt is 3. This is correct. Okay, t given from 0 to pi over 2. And then you find the ds, which is square root of dx dt squared plus dy dt squared plus dz dt squared dt. Hence you get 4 cos squared t. Okay, 4 cos t squared it, negative 4 sin t, you squared it. So the first two term you have 4. Okay, the first two term you have got 16 plus 3 squared, which is 9. Then you got the first, okay, two term you simplify it, 16 plus 9. So total is square root 25, you get 5, which is correct. So ds is 5 dt. Don't forget here, 5 dt. ds is 5 dt. So x replaced by 4 sin t. Okay, and then the y replaced by 4 cos t cube. So, okay, this is 5 dt. And you use a calculator, you obtain the answer 320. Okay, which is, okay, correct. Okay, 320, correct. Yeah. Okay, so, okay, those who have Soleha, okay, congrats, okay, you have did it correctly. So mean you, okay, if the C is given directly, you should be able to do it. So if the question is a little bit higher, then will be like other question that we discussed, okay, just now, where you need to define your own parametric equation. So if circle, then you use, okay, the technique, okay, the equation similar to x equal to r cos t. I mean, similar to r cos, x is r cos theta, y is r sin theta, where r is the radius of the circle, and then theta we change it to, okay, t. So, okay, if we use the polar equation technique, the t is actually the direction of the curve is always, okay, is always anti-clockwise. Okay, or you have the equations, okay, if this is not curve, this is not straight line, then you have to look at the equation. If like, let's say just now, which equations are the curve y equal to x squared or y equal to x. Okay, which one already? 1D, 2C, like question 1E here. Curve y equal to x squared. Let the variable at right hand side as a t, then y equal to t squared. So you see x move from 0 to 1, then t also move from 0 to 1. Or you may have the vertical line. Okay, this vertical line at x equal to 1, then let y equal to t. Y move from 1 to 2, then t move from 1 to 2. Okay, or you have the horizontal line like question 1. You may use the, okay, parametric equation for a straight line, or you see 0, 0 to 0, 1. This is on y-axis. Y-axis, let x 0, then y equal to t. If the line is on x-axis, then y equal to 0, let x equal to t. Okay, so these are some trick to get the parametric equation, okay, for x, y, z. Okay, and then so we look at the exercise 4e. So, okay, this is not scalar field differential form. And question 1 is on 2D. Okay, here also should be line integral of differential form. differential form. Also, this is a line integral of differential form in 3D. So if line integral of scalar field is in this form, fxyz ds along curve C, okay, if fxyz represent the density function, okay, this one can represent the m. It's a mass, okay, mass of curve C. If fxyz represent density function, then this integral, okay, the line integral of scalar field can represent the mass of a curve C. Okay, if the fxyz equal to 1, this represent the arc length. Mean the arc length. Okay, arc length of curve C. Okay, mean is the integrand is 1, so 1 ds. So you have the length times the density, you get the mass of the curve C. Because, okay, as you know that, okay, in physics that you learn, density is a mass divided by volume. But, okay, curve here only consists of length. So your density also can be mass divided by length. Okay. However, the density function here is not variable, it's not constant, it's variable function. That's why if this represent the length, so now the fxyz represent the density function, this will represent the mass of the curve C. So please, okay, think the understand the meaning of the application. Okay, we may have, okay, the following quiz asking you about all the meaning of the, okay, the integral that you learn. Okay, and then now the line integral of differential form. Let's say question 1, evaluate the integral 2xy dx plus x squared plus y squared dy, where C is a circular arc given by, okay, x is cos t, y is sin t, t from 0 to pi over 2. Okay, question A and B also, okay, direct question, because the parametric equations mean the curve C, the parametric equation for curve C is given directly. Okay, we show question 1A. This is direct question. This one where you need to, okay, where you need to express your own parametric equation. Question 3 also, but this line segment, this is a curve x equal to set y from point 0, 0 to 1, 1. Okay, we look at question 1 first. Question 1 is direct question. Hold on, we look at the exercise 4E, question 1A. Those who who didn't buy the module, you can get the exercise, okay, from the author. Okay, evaluate, okay, the line integral along curve C 2xy dx plus x squared plus y squared dy, where, okay, question 1A, where the curve C is defined by x equal cos t, and then y equal sin t, t from 0 up to pi over 2. So if differential form, this one you have dx dt. Dx dt is negative sin t. Then, because you want to replace, dx will be negative sin t dt. So similarly, I will quickly, dy will be cos t dt. So replace dx by negative sin t dt, dy by cos t dt. And then x replaced by cos t, y replaced by sin t. Okay, then from here, you have t from 0 to pi over 2. So from 0 to pi over 2. Okay, 0 to pi over 2. And then, okay, x replaced by cos t. Okay, y replaced by sin t. Okay, for the first, okay, for the dx there, dx replaced by negative sin t dt. Okay, so you got 2 cos, x is cos t, y is sin t, dx is negative sin t dt. Okay, and then you add up here. Okay, x cos t, so cos squared t. Y is sin t, so this is a sin squared t. Okay, dy is cos t dt. Okay, you may simplify. So 2, and then this one dt, later on you can factor out dt outside. So 2 cos t, so negative 2 cos t, you have sin squared t dt, we factor out outside. This one cos squared t plus sin squared t is 1, so mean add up with cos t. So total dt. So you see, x replaced cos t, y replaced sin t, dx replaced by negative sin t dt. So x squared is cos squared t, y squared is sin squared t, dy is cos t dt. Simplify, factor out dt outside, and then you may directly using the scientific calculator. Okay, just make sure you input correctly. So I can put there because I got two terms. I okay, try to be safe. I put open, close the bracket. So negative 2 cos. Okay, and then you got sin squared. I put another bracket for sin. Close the sin squared. Add up with cos. Okay, close. T from 0 to pi over 2. Okay, I get the answer 1/3. Question 1a. Answer A and B, 1/3. This is a question 2b. Question 2b, cause similar, okay? Just now exercise 4D, we have seen the path y equal to x squared, where let the variable at the right hand side as a t, so x is t, so y is t squared, x from 0 to 1, that's why t from 0 to 1. Question 2b, okay, let the variable at the right hand side, which is y, is t. Then x equal to t squared, because you let y equal to t. And then y from 0 to 1, this is y. Then y equal to t. So t also from, t will be from 0 to 1. So any problem, okay, for question A and B to find the parametric equations.
So far, no problem, Doctor.
Okay, if no, then from the x, okay, from the x equal to t, from y equal to t, then you find dy equal to dt. Okay, this one is okay. Dy equal to dt, and then x is t squared, dx is 2t dt. Is it okay? And then,
Okay, okay, Doctor.
yeah, then plug in into the line integral. That's why you have y is t, dx 2t dt, x is t squared, y squared will be t squared, dy is dt, t from 0 to 1. Just make sure you plug in correspondingly correct. Okay, check y plug in by t, dx plug in by 2t dt, so plus x is t squared, y is t, so t y squared is t squared. Simplify and then use a calculator to integrate it. So you got total 2t squared. 2t squared. Okay, dt we factor outside. So this is plus t power 4 dt. Then quickly use your scientific calculator to integrate it. So open the bracket. 2 alpha x squared plus alpha x power 4. Okay, x from 0 to 1. You have the answer 13 over 15. So question 2b, you get the answer 13 over 15. So question 2, we have the same line integral, same starting 0, 0 to 1, 1, but different path. So you can see different path, the line integral you should get different answer. So this one shows that line integral is dependent of path. Depends on path. This is path y equal x squared. This path x equal y squared. So different path will give you different answer. Mean like you use from Pariraja you want to go to KL, you may use highway, you may use old trunk road. So different route you have a different cost there. So this is you see the same line integral starting ending Pariraja to KL. Okay, one using highway, one using old trunk road. The costs are different. So this is what line integral depends on path. It's dependent on path. So theory, please make sure you understand it. We have the later on the quiz regarding the theory part here. So so you can try the question 2a. Okay, or I give you the parametric equation x is t, y is t squared. So similar way, evaluate it. Okay, you should obtain the answer given in the module 13 over 21. So this shows that the same line integral, same starting ending point, but different path, you have different answer. Okay, because the curve y equal to x squared is actually from here. This is y equal x squared. X equal y squared is like this. Then they are crossing at this is 1. This is 1. Okay, this is x equal y squared. Y equal x squared is actually your parabola open up. This is y equal x squared. Okay. This is x equal y squared. X equal y squared. The parabola open at the right hand side. So these two curves, you have different curve, same starting ending point. Normally, the line integral is dependent on path, except later on when you learn conservative vector field. So this is a question 2. So I solve B. You go back to solve the question A. This one you go back to solve question B. Okay, and then again. Okay, question 3A. Straight line from the point 0, 0 to 1, 1. Okay, this one 0, 0 to 1, 1. Okay, so this is a linear linear graph. Okay, we see question 3A. Okay, question 3A. Evaluate the line integral xy dx plus x plus y dy. Okay, question 3a. The curve C is actually straight line. Straight line from 0, 0 to 1, 1. Okay, you can easily see. Okay, this is a point 0, 0. Okay, 1, 1 is a linear. Okay, this is x1. This is y1. So this point is 1, 1. 0, 0 to 1, 1. So easily you can let this straight line is actually y equal to x. So when x0, y is 0, and x1, y is 1. So y equal to x, then you can let x equal to t, then y equal to t. Then so dx equal to dt, dy equal to dt. So plug in x is t, y is t into the line integral there. That's why you have, okay, from here. Okay, and x move from 0 to 1. That's why t move from 0 to 1. X is t, y is t, dx is dt, then x is t, y is t, dy is dt. Okay, so simplify and then use the calculator to integrate it. So you got t squared, factor out dt outside, t plus t, so you got 2t dt. So you integrate. So t change to x in your calculator. X squared plus 2x. Okay, x from 0 to 1. So you get, okay, the answer 4/3. Okay, question 3a that we solve. Okay, 3a 4/3. So any question? Okay, for question 3a here. 3a.
No, doctor.
So similarly, if 3b, you will let the variable at the right hand side, which is y equal to t. 3b, the same line integral but different path, you should get different answer. 3b, okay, you should get different answer. Okay, 3b, the same line integral but different path. You got, okay, see, this is x, y, dx plus x plus y, dy. Okay, but your curve C is given by x equal set y. And then from 0, 0 to 1, 1. Okay, you may if you want to eliminate the set y, you may square it, so you have the x squared equal to y. Okay, x squared equal to y, or y equal x, okay, or y equal x squared. Then you have here y equal x squared. Then I may let x equal to t, then y equal to t squared. Okay, let's see. So then dx equal to dt, dy equal to 2t dt. So that's why the line integral here. Okay, x from 0 to 1. X 0 to 1. Okay, that's why. So t will be from 0 to 1. Cause here, cause x equal t. Okay, later on you can check if you let y is t. If you let y is t, then x you got set t. So set, okay, if you manually integrate may be a little bit difficult, but if you use calculator, doesn't matter. Okay, later on you can go back to check if you can try later on. If you let y equal to t, then x is set t. To eliminate the set, I squared both hand side, so I get x squared is y, or y equal x squared. Then I let x is t, then y is t squared. So t from 0 to 1. Okay, x is t, y is t squared, dx is dt. So x is t, y is t squared, dy is actually 2t dt. Okay, for line integral is dependent on path, mean different path, even though starting and ending point same, you may have you must have a, normally you get the different answer, except if the vector field is conservative. And then, however, line integral doesn't depend on the parametric equation. You may use x is t, y is t squared, or you may use y is t, x is t. You should get the same answer. Okay, so let me check. So x is t, y is t squared, dx is dt, x is t, y is t squared, dy is 2t dt. Simplify and then use the calculator to integrate it. So you got t cubed, factor out dt. So this one, t plus t squared multiply 2t. So mean you got, okay, so plus 2t squared plus 2t cubed dt. So this one 2t squared, this is t squared times 2t cubed. So 2t cubed plus t cubed, so its total is 3t cubed. Okay, simplify, okay, then you put it to your calculator. So total is 3t cubed lah. T cubed plus 2t cubed, total is 3t cubed plus 2t squared dt. Okay, you got here 3. So t change to x in calculator. Cube, sorry. Cube plus 2 x squared. Okay, x from 0 to 1. Okay, answer, okay, 17 over 2. 17 over 12. This is question 3b. So 5 over 12 is 17 over 12. So this one I use x is t, y is t squared. If you want to use, okay, if I said normally let the variable at right hand side as a t. So you let y t, then x is set t. If you want to use this way also can. Okay, 3b. Okay, it sees the 3b. The line integral xy dx plus x plus y dy. C is x equal set y. And then from the point 0, 0 to 1, 1. Okay, if you let y equal to t, then x will be equal to set t. Also can just you meet with the square root. Okay, so dy will be dt. Okay, dx. Okay, remember this is t power half. So dx is half. Then t for differentiation, bring the power in front, so half, and then power will be decreased by 1. Half minus 1 is minus half. Okay, minus half, and then you got dt. Okay, and then you plug in from here. Okay, x is set t, y is t, dx is, you got half t power negative half dt. So, okay, x is set t, y is t, dy dt. Because you use calculator, okay, if you use manual, mean a little bit too difficult to integrate, but you use calculator, still okay. Okay, you may simplify everything. Cert is actually power half, t power half, and then multiply t minus half. So this is become cert t is t power half. So multiply with t power negative half. So half plus negative half, t power 0, which is 1. So it's just left half t. Okay, dt factor out. So this one you have cert t and then plus t dt. Okay, simplify. Half t plus t total is 3 over 2 t plus cert t dt. Okay, check. You have the 3 over 2 is 1.5. T change to x. Okay, I will prefer to put bracket because we got two terms plus cert x. Okay, then x from where to where? Okay, y equal to t, y from 0 to 1. Okay, y 0 to 1 because y equal to t. That's why t also 0 to 1. So the t is the x in the calculator, which is 0 to 1. You get 1.4167. 1.4167. Okay, just now we obtained here. Okay, we see this answer. Yeah, same. 12. Okay, 17 over 12 is 1.4167. So you can see that question 3b, if you directly let the variable at the right hand side y equal to t. So dy is dt. So dy is dt. If you let y is t, then x is cert t. So cert t is t power half. So dx dt is half bring in front, and then t power half minus 1 is minus half. So dx is half t power negative half dt. So x is cert t, okay, or cert t, or is actually t power half. So y is t. Dx is half t power negative half. So t power half multiply t power negative half, you get 1. So just left half of t, okay, half of t, dt already factor outside. Okay, x is cert t, y is t. So here, so half t plus t, 3 over 2 t plus cert t. Using calculator, you get 1.4167. Okay, and then if I don't like the square root, okay, I don't like the square root, I can square both hand side. Then x squared equal to y. So if you let yt, then x is t squared. Okay, another way also, if I say variable at the right hand side, then if you let yt, also you can, then y is t. Oh, then y is t, then x is cert t. Same as just now. Y is t, then x is cert t. So the same parametric equation. So if you let y is t here, then x is cert t. Okay, I don't like the cert, that's why I squared it and I turn it. Y is x squared, let x is t, then y is t squared. Then I perform this way. If I choose this way because I don't like the square root there. Square root, when you differentiate, we have the fraction half. Then we perform it, we get 17 over 12. Okay, change to floating point 1.4167. This one using x, y is t. You get the answer 1.4167. That's why, okay, these two different parametric equations on the same line integral, we get the same answer. means, okay, in the lecture we have shown that line integral doesn't depend on the parametric equation of, okay, your x, y, z there. Okay, as long as you get the same curve, the same line integral, okay, doesn't matter which parametric equation that you use, you should give the same answer. So that is the first note, okay, on the line integral. Line integral doesn't depend on the parametric equation. You may have, okay, different way to define a parametric equation, but it should give the same answer. However, line integral actually dependent on path. You can see the path y equal x squared and x equal y squared, even though same starting and ending point. Okay, we should get the different answer. So we have shown, okay, I think question 1a, 2b, 3a, 3b, and then okay, so the rest, okay, you have to do it on your own. Okay, this is a piecewise smooth. You have to do C1, C2, C3 3 times. This one 4 curve, you have to do the line integral, break the C into C1, C2, C3, C4, so if 4 times work. This one C1, C2 2 times works. And then the rest, okay, this is on a 3D space, so add up the Z variable.